So in this video, we are going to discuss about ring counter. It is same as a shift counter, but here you can see this flip flop. I can use if it is a 3-bit ring counter means I can use 3 flip flop. If it is a 4-bit ring counter means you have to use 4 flip flops because each flip flop will store 1 bit. So it can be of D type, D, T, or JK flip flop you can use. So what is the difference between the normal counter and shift register and the ring counter is the last output of the last flip flop is connected to the input of the first flip flop. Okay, so it is connected like this. So you can see this will form a ring. So that is why it is named as a ring counter. Okay, so here you have a preset pin. Okay, preset. So with the help of preset pin, I can make this output of the flip flop 1 as 1. So and the rest of the output of the flip flop is 0. Okay, so I can say the initial state of the output of the first flip flop Q1, Q2 and Q3 is 1, 0, 0. Okay, so whenever I apply a clock, the clock may be a positive edge triggered. Okay, if I give a clock means during the positive edge of the clock, what will happen? The output will move like this, right? So the output from here, output of the Q3 flip flop will come to the Q1 flip flop. First flip flop, right? So the output of this one will come here, and the output of this one will come here, right? So it will get shifted, right? So it will get shifted from here to here, then from here to here, then from here to here, right? So it will move like this. So again, if I give the clock, so from here it will go here, right? So from the output of the Q2, it will go to the output of the Q3. Next, the output from here, it will go to the first state, right? Next, again, if I give the clock, means it will show as 1, 0, 0. So you can see it is getting repeated. See 1, 0, 0. Again, I'm getting 1, 0, 0. So if I give again clock pulse means it is repeating like 0, 1, 0, then 0, 0, 1. So I can fix the state like this. So if I have 3 flip flops means I have only 3 states. Okay, so this is my state 1. Okay, state 1, 2 and 3. So if I have 3 flip flops means I have 3 states. If I have 4 flip flops means I have 4 states. So you can verify by yourself. So here you can see it is a type of a digital counter which is used in the circuit, which is made up of flip flop. And here you can see the one get shifted like this, right? So the one get shifted like this through a series of flip flop during at one time in a loop. So that is why it is called as a ring counter. So here you can see only 1 bit in the counter is set to the 1 and the rest of the value at a time, right? So it will form the pattern of bits, it will form a cyclic behavior, right? So let us discuss about the advantages of this circuit. Okay, so it is very simple, right? It is easy to design, and it is used for small applications, and it uses low resources, right? So you don't need a lot of component. You require only a D flip-flop or the T flip-flop, and you will get a predictable output. So it will always go through the same set of states in the same order, right? So and it is easy to decode. That is, each state is distinct and easy to decode because it uses only one hot encoding. Only one output is high at a time. So that is called as one hot encoding, and it will produces a glitch-free output. Since only one flip-flop is active at the time, there is a less chance of the output glitches will happen. So it is more reliable in certain applications. So what are the disadvantage of the ring counter means it has limited states, right? So you can only cycle through as many as states the number of flip-flops in the counter. If it is a 4-bit means you require a 4 unique states, not more than that, right? So it is not used for a complex pattern, right? So it is not great if you need a counter that counts in the random or non-binary pattern, since it is limited to a cyclic pattern of the shifting of one through the flip-flops, and it needs a initialization, because with the help of preset only we are making one flip-flop initial state of the flip-flop to 1. Without preset we can't be able to perform this ring counter. Next, hardware cost will get increases. So if you want to increase the number of states, the number of flip-flop will get increases. So it becomes a bulky if you require a large number of states. So that is another disadvantage. So now let us discuss about the applications of the ring counter. So it is used when you need a system that go through a specific repeated set of states. For example, it is used in the predictable sequence, is as simple as control system or timing circuits. Then it is used in the control systems, it is used for the things like multiplexers or encoder circuits, where the order of the operation need to follow a certain cycles, and it is used in the simple designs because it is easy to design and understand, because each state has only one flip-flop that is set to 1. So it will making the debugging analysis straightforward, and it is used in the finite state machines. Whenever a system which that moves through a known set of states in a loop, which is example like elevator control or vending machines, right? So if you put 5 rupees coin, you will get what are the product which is of 5 rupees cost, right? Then it is used in the shift based applications, ring counters are the special type of shift tracer which are used where the shift tracers are need for data movement. So these are the applications of the ring counter. So next we will discuss about twisted ring counter. Okay. So what is the difference between twisted ring counter is here also if I have so instead of taking the output from Q, I am going to take the output from the Q bar. Okay, Q bar, and suppose if I if the initial state is 100, with help of preset I have fixed the value as 100, and what I am going to do, so instead of 0 it's coming to the Q1, it has to be inverted. So if it is inverted means I will get 1, right? So this is same as the ring counter, and I will get 100 whenever clock goes to positive. Again I am getting 1 1 1 because this gets shifted and the inverted value is shifted here, right? Again if I apply the clock, the inverted value will come here, and I will get 1 1. Again if I give a clock, right? So the inverted value will come here. So 0, 0, 1. So again, if I give a clock pulse, you get 1, 0, 0. So you can see instead of I'm getting so since I have used 3 flip-flops, 3 flip-flops, instead of getting 3 states, I'm getting a 5 state, right? Sorry, this is 0, right? This is 0, 0, 0. So if I again give a clock, it becomes 1, 0, 0. So it is getting repeated. So you can see if I have 3 flip-flops means I have nearly 6 states, right? Double to that of ring counter. So if I have 4 flip-flops means you can tell me in the comment section how many states you require. Okay. So this to serve a ring counter is also called as a Johnson counter. Okay. Or switch pay ring count, or it is also called as walking ring count. Okay. So here also it is the advantages. It is very simple, and it uses very low resources, and you will get a predictable output and glitch free, and it is easy to decode. Similar to that of advantage of the twister ring counter, right? So I hope this video is useful for you. Thank you.